Suppose the prices of a certain guitar are normally distributed with a mean of $159. What is the probability that a buyer would pay more than $150 if the standard deviation is $15? Since it says that these are normally distributed, we can start off with our normal distribution. In the middle, we're going to put our mean. So here our mean is $159. And we want to know what's the probability that they would pay more than 150. 150 is to the left of 159. It's smaller than it. And we want to know if they're going to pay more than 150. Not 150. So I'm going to shade to the right-hand side. Now, we need to find out what our z-value is so that we can use our standard normal probability table. Z is going to be x minus the mean divided by the standard deviation. In this case, our x is 150, our mean is 159, and our standard deviation is 15. $150 minus 159 divided by 15 gives us negative 0.6. Our z, therefore, is negative 0.6. Once we know our z value, we're going to have to use our standard normal probability table. Now, our standard normal probability table gives us area to the left. The table is going to tell us this area. But we want the area to the right. Therefore, our probability that they pay more than $150 is going to be equal to 1 minus the probability that they pay less than $150. This is the value that's going to come from the standard normal probability table. We go to negative 0.6 on our probability table. Here is negative 0.60. It's 0.2743. And when we find that, we find out that the probability that x is greater than 150 is 0.7257. A good way to check your answer is to look back at your picture. Notice we shaded more than half of this normal distribution. If you forgot about subtracting from 1, your answer would be 0.2743. And we would know that that was incorrect because of the fact that 0.27 is 27%. That's less than half. And we know from our shading that we needed a number that was more than half. Therefore, we would have been clued in that we needed to do some more work.